Welcome guys. To solve this equation, let us expand this bracket because we know that a minus b all squared is the same as a squared plus b squared minus 2ab. So we're using that exact same identity here. Therefore, the expansion of this will therefore give us 3 to the power of x all squared plus 2 to the power of x all squared minus 2 times 3 to the power of x times 2 to the power of x, and that gives us, using the law of indices on 6 to the power of x, we can rewrite it as 3 times 2 all to the power of x, right? And according to the law of indices, we can share the power and say 3 to the power of x times 2 to the power of x. So let us rewrite 6 to the power of x as that. That will be 3 to the power of x times 2 to the power of x. So let's go ahead to divide the equation by 2 to the power of x all squared. Therefore, we're going to have 3 to the power of x all squared, then divided by 2 to the power of x all squared. Then also divide this as well, divided by 2 to the power of x all squared, then minus 2 times 3 to the power of x, 2 to the power of x, then divided by this, and it gives us 3 to the power of x times 2 to the power of x divided by 2 to the power of x all to the power of 2. So therefore, when we simplify this, and according to law of indices, these two have the exact same power. Therefore, we can combine them and make them share a common power. So we can say 3 over 2 all to the power of 2x, then plus. So this cancels this, they're exactly the same. And then we have 1 minus, and also this is squared, so we can just get rid of 1, and we have 2 times 3 to the power of x divided by 2 to the power of x, and that equals, same thing applies here also, we cancel out 1 because this is squared, and then we have 3 to the power of x divided by 2 to the power of x. So here now, these two have the exact same power, so we can combine them, same as this. We can combine them together according to the law of indices. So therefore, our equation will now be reduced to this plus 1, then minus 2 times. So we have 3 over 2 all to the power of x. And that will be equals 3 over 2 also all to the power of x. From here on, we can use a brilliant substitution because they all have the same base. So we can just say let 3 over 2 to the power of x equals y. So this substitution helps us to break down the equation. So therefore we have y squared, because we can interchange the position of 2 and x to make our substitution more valid. Then plus 1 minus equals y. So then when we transpose, we have y squared plus 1 equals 0. And then when we solve this quadratic equation, y squared minus plus 1 equals 0. So when we solve this quadratic equation using whatever method we like, we'll find out that y approximately equals 0.3897 and also approximately equals 2.6180. So let's go back to our substitution. We have 3 over 2 to the power of x to be equals 0.3897. So we can take logarithm of both sides. So we have x ln of 3 over 2 equals ln of 0.3897. So we have x to be equals to ln of 0.3897 divided by ln of 3 over 2 is 1.5. So then that makes x1 to be approximately negative 2.3242. So that's our first value of x. So also we have 3 over 2 all to the power of x to be equals 2.6180. So taking ln of both sides, we have x ln 1.5. Then that equals ln of 2.6180. So therefore, we have x2 to be equals ln of 2.6180 all divided by ln of 1.5. So therefore, x2 will approximately equals 2.3736. Correct.